Okay, so welcome back. This is part 3 in our series where we're helping you to understand the basics of a very, very important concept used in the real world, and that is the concept of a state machine. And a state machine is used to control real world equipment. And we're using as an example what you see here, something you're probably very familiar with, and that is the control of traffic lights at an intersection. And that uses the concept of state machines. Now, we've talked previously in another series about another type of real-world equipment control system that's called a feedback control system. And that's used, for example, in your car when you're on cruise control. It checks to see what the present speed of your car is. And if it's not where you set it, it adjusts the engine to speed up or slow down to continually maintain the set speed. And that's a feedback control system. What we're talking about in this series is a state machine control system that controls the equipment to be in specific states at different times. Now, I encourage you to look at the previous videos where we have talked about the basics and developed a very simple conceptual logic to control this state machine. And we also started developing this application you see here, which basically simulates a state machine control system to control traffic lights. And I can start it, and you can see it automatically emulates these traffic lights at the intersection where it sets red for the vertical traffic and green for the horizontal traffic. Horizontal traffic gets a yellow light, then a red light. Now the vertical traffic can go. And we showed you how to develop this very simple application that really helps us to understand the state machine and how you implement it. Now, we also talked about some limitations in our application, and these are some real-world issues you need to understand and address if you're dealing with state machines in the real world. And we said there were some optimizations and changes we need to make in our code. So in this video, we're going to take a look at some of those things and see if we can figure out how we can improve on our state machine simulation. Now, the first thing you might notice, if you generate this application as we have so far, it kind of works where it goes through and it simulates the lights changing color for the different traffic flows. However, one thing that we can't do is I can't, for example, select this form and I'm clicking on it trying to drag it. I can't do that. And the reason is because what we've done is we have set up an endless loop to continually populate this form with the changing lights and also to do the time delays for each of these. And basically our entire application is busy doing that one task synchronously, and it doesn't have time to do anything else like respond to input from the user and that kind of thing. And we've done videos before talking about what's called asynchronous tasks. And what we did is we used this simple example where we have, for example, a supervisor who's got some robots, and the supervisor asks the robots to perform a task so that the supervisor can go on and do other things. So we talked about that basic concept that we can implement in this application to allow our supervisor or our user interface, our main task, to go do other things while a separate task goes off and does our simulation. And now here is a modified version where I've applied this asynchronous tasks to our application. And you can see it's a lot snappier. The timing seems to be a lot more correct where simultaneously the lights change. And also I can move this user interface. And this really helps the application to be a lot more efficient and correct. And it's something that when you're dealing with state machines, you really need to be aware of. You need to know how to deal with that because this is what happens in the real world. So let's take a look at our application, see how we can implement that, and then look at some more next steps to see how we can improve our application. And we also talked about things like, this isn't always exactly the same timing. Sometimes we can have what are called occupation detection sensors, where if a car shows up at a traffic light, the application uses that information to change the timing to give weight. If there are more cars looking for the light to change, it will change the timing of the lights. So let's take a look at how we can implement some of those things in our application. So here is our application we developed so far. Again, C# Visual Studio Windows Forms application. Again, you can use any programming language you want. The same concepts apply, but we're just giving you an example here in C#. And the basic application we have is we've got our start button and our stop button. And when we click the start button, we set the run boolean to true and then call this run sim method. And the run sim method is up here. And while that run boolean is true, which is always, it goes through and calls this set state method sequentially to set state 1 to allow traffic flow in one direction, and then set state 2 to turn the green lights to yellow, and then set state 3 to give a green light to the opposing traffic, and then set state 4 to change those greens to yellows, and then it just loops through and does this. And again, this is the main thread. We can call it the supervisor. That is basically, that's all this application is doing, and there's no time to do anything else. So what we want to do is we want to change this. Instead of doing this run sim that just its only task is to run this, what we want to do is we want to implement what we talked about in the previous series on asynchronous tasks. We want to run this run sim method as if it was a robot going off and doing something, but the supervisor who asked the robot to do this run sim can go off and do other things. And the supervisor is basically the user interface that will allow us to interact with the user interface and also do other things like recognize occupation detection sensors and so on. So what we want to do is, instead of just running this run sim, we want to run this asynchronously as if it was a robot going off and doing something, so that our main thread can continue and do other things. So what I'm going to do is I'm going to add a line here where I am, instead of calling this run sim synchronously, I'm going to call it asynchronously. And I'm going to make a method called supervisor async, which basically calls this run sim asynchronously, so it will go off and be done on a separate thread. So run equals true and then supervisor async. And here is our supervisor async method. Very, very simple. But as we talked about in the series on asynchronous tasks, it's a public async void and it's supervisor async. And all it's going to do is it's going to do a task.run, and it's going to run this sim on a separate thread. So we are basically awaiting this task.run, run sim. So now it's basically the supervisor is telling the robot, okay, go off and do this run simulation. I'm going to go deal with the user interface and any other inputs we get from like an occupation detection sensor. So now when we run this, we can hit the start button and we can move this around, and all of the signal changes are very snappy because it can do it in real time without having to worry about the UI and so on. So a really big addition to this application with only a few lines of additional code. Now, what else do we need to do? Well, you can see we've got this going where we've got the red lights and now the green lights have changed for the vertical traffic. Let's say I want to stop, and this stop button basically changes the run boolean to false. So the simulation should stop, but what we see, it's still going. And now we've got the vertical traffic has green lights. These are going to shift to yellow. And now it seems like it has stopped. So what's going on here? Well, keep in mind that when we do the stop button, we say run equals false. However, it doesn't check for that run boolean until it has gone through all of these four states. Then it goes back in the while loop to check, is run still true? So when we set this run equals false, it has to go through all four states before it checks. So that's something to keep in mind, that it's not going to respond immediately. And when we're going to add some inputs for like occupation detection sensors, we're going to have to keep in mind that we're going to have a separate thread running that's doing the simulation. We're going to have our occupation detection sensor information, make sure that it is being addressed in real time and it's not off and being blocked by this thread. So now that we have improved our software application to be very responsive and work pretty well to do our simulation, what are some other things we need to think about when we're going to develop a real-world state machine application? Well, as you can see here, we've got the logic in our software state machine. But at the end of the day, one thing that I know software developers tend to try and avoid is the real world. And in the real world, we're going to have to connect this software application to some hardware to actually control lights. So let's start thinking about how you can actually do that. You know, what type of hardware are we going to need? As we said before, if you've ever seen traffic lights, you can probably assume that they're drawing fairly sizable current, and you're going to have some hardware that's going to be able to operate those lamps, but take a very low voltage signal coming in to operate them. And previously we've talked about, in a series about DC relays, we talked about what is a relay, but they're extremely important hardware components. And in our case, we're going to take a look at how we can use very low-level logic signals generated by our software and convert those to high current, high voltage switching of these individual lights to operate our signal. So let's take a look at how we might do that. So here is just one example of a device you might see in real-world state machine control systems, and it's called a relay. And we did a series talking about what is a relay, and in particular we looked at this device, which is really nice because it allows you to take a very low level, low voltage, low current logic signal and control these blue boxes, and each one of these is a relay. And it takes a low level signal and it passes it through an optocoupler, and that isolates the logic signal coming in from the high power requirements of this relay. And it's basically an electromagnetic coil that closes some contacts, and you can see here we've got the outputs, and we can connect these to the light. It can control a 250 volt AC circuit up to 10 amps. So really nice. You can take a low voltage signal from a device such as this Arduino, and you can connect it directly to this and control some very high power circuits such as our traffic lights. So now we know that we can develop a circuit with low voltage, low power logic signals and actually control our lights. And it also tells us these are fairly large mechanical components and they're going to take time to operate. So another thing you have to consider in your logic for your state machine controller is the time it takes for these relays to operate, and make sure that you've got that calculated in your state machine logic. So the real world gets into your software design where you have to consider things like that, time delays and so on. So let's now take a look at some other steps we need to take with our state machine controller and see what we need to add. So now we have a bit more insight and understanding into how our entire controller state machine is going to work. We know that there's some hardware involved. We know that there's some software. We'll probably have a circuit board that has got some integrated circuits on it that do all of this logic. And again, the goal here is to, from our own understanding and knowledge, try to generate a very conceptual framework of the logic and all of the components without going on the internet and trying to search for the answers. The way you learn is you figure it out yourself and you try to design all of this without looking at any resources and try to figure out how it would be and what you might expect if you were to see a real one. And then hopefully at the end of all this exercise, you have enough knowledge and insight into what you expect that when you look at the real thing, you'll say, ah, okay, I know what all that is. I know what these little blue boxes are on the big circuit board that does the controlling. Those are to turn on the lights. Maybe it's not exact, but at least it will give you some insight into what to expect rather than just going in blindly and looking at how it's done and say, okay, I'll copy and paste that and now I'm an expert. So the goal here is to try to use our own understanding and figure out how this might be done. In the next video, we're going to take a look at some of the external inputs that we might expect. We said they're occupation sensors. How would we integrate those with the logic and with the hardware and the built-in timers that we expect to have? How are those occupation sensors going to be integrated into all of this logic? So that's it for this one. If you like any of these videos, I encourage you to hit the like button, subscribe, hit the bell notifications. But most of all, please let others know that we're here so we get some views. Really appreciate it. Otherwise, take care. Have a really good day. Thanks.